Yes, dear students, we are ready for the next 5-marker question. And this is from model paper number 2. Yeah, still we are going in reverse order only. And there is a reason for this. Okay, just wait and watch. Let us complete this problem. Then you will just see model paper number 1. Question is on ellipse. In no time we can finish. Okay. Question says, using the method of integration, find the area enclosed by the circle. And the circle equation is given by x square plus y square is equal to a square. Actually, in the model paper, question is still here only. I have added this extra because as per my experience, previous year annual board examination, they have also included I repeat, they have also included sub problem like this. Okay. So first we will complete this, and this will not take too much of time, hardly 1 line answer. Okay, I know you may thinking, start giving extra, hardly 2 lines. Okay, and in case it comes, you are benefited. Okay, let us not learn something less. See what I'm trying to say. No, now we are going with model papers. I'm not degrading what I'm going to say. It is just what I want you to realize and understand. Everyone know, for example, what I'm saying. No, everyone know. Assume for a while this is pizza. Now what is happening? No, this is what important question. Think as important questions, and it should not happen. No, I want only this pizza part in this entire important question. I want this. I don't want this particular part. I don't want this particular part. When you are going to ignore like this, no, who knows if this comes, you are in trouble. So kindly don't get demotivated, etc. Time is there, and I will assure you that all these solutions I am going to solve. Okay, that is sure with the concept. Okay, with that intention, with this intention only we have started this. No, I have launched this channel. Okay, so be careful. It is just I want you to be clear that I will not leave anything. Okay. Right, is this? It's nowhere to demotivate or what sir is talking about. It's just to motivate you and make understand that nothing should be left by you. So let us go ahead. Okay. Solution of this. This is a circle, and even if they have not given this, as you know, whenever degree of x and y is 2. And its multiples are positive and equal, it's always a circle, provided right hand side is a positive number. Okay, now let us try to draw the graph of this. First I will draw the graph here. I think this space will be sufficient. X and y axis I have drawn. I think y axis is a bit bending for a while. Let I draw it correctly. Okay, make sure in exam use pencil and scale to draw it. Now I have a circle. Yes, fine. And make sure the circle covers all the area. Okay, it's equally. Now see this. I want to find area bound. Enclosed means bounded. Enclosed means bounded. Okay, enclosed means bounded. And see, I want to find this area, this area, this area, this area. We are not going to find all. Okay, we know that whatever area is there here, all are same. So let us write one by one. First, you see this particular area, let us shade that, is bounded by both the coordinate axes, y also, x also. Whenever for bounded figure it is bounded by both the x and y axis, we always prefer x axis, because we have been trained or we have been used to solve with respect to x all the integration problem. So it's better to go with x. No, so I want to go with respect to y. Make sure nowhere when you are solving, x should come if you are taking y axis, nothing but horizontal strip. Fine, so both will give same answer because it's a bounded figure. Now see carefully, this particular curve I want in the form of y equal to f of x. So solve this one for y. Let us write down the equation first. Solve for y. I will sum of two term. I can transpose here. So I will get y square is equal to a square minus x square. I want only y, as you can see here. So when I take the root, actually I should write plus or minus. I repeat, plus or minus, but I am not writing minus here because I am only focusing this part. And this particular curve which is present here, this is present here, is where? Above which axis? X axis. Above x axis, y is always positive. So plus. Okay. Now, because I know when you take square on both the sides, so it will be asking for equation something like x square equal to 4. If I give you x square equal to 4, sir, when you are going to take the root of this, it is what? Plus or minus 2. Yes, it is correct. Because of this itself, I gave the reason that when I am taking root, it's not plus or minus because I am focusing only this part of the curve. Okay. If I could have taken entire, then plus or minus. Okay. Now, this is the origin here. Okay. Now I want to find the area of the circle. So area of the circle is 4 times of, why 4? 1, 2, 3, 4. I'm only focusing on this. 4 times of shaded region. Now coming to this vertical, I should also talk about the boundary. Don't forget, this is radius. And from circle concept, this is a circle with center origin. Let us have some knowledge here. And radius of this circle is only this here, without the square. So, since this is the radius and this is your x length, so this particular line will be a vertical line touching the circle, and this will be x is equal to a, and this is y axis, which will be x is equal to 0. This is x is equal to 0. Now I have seen many students when they draw this tangent, no error from them, you see. I just trying to make you precaution. Okay, some of the students try to draw this tangent because it's a tangent here. Some draw like this. I mean, this is correct. I mean to say, some draw like this. It's nowhere touching, and some student draw cutting. Both are not accepted. Make sure, surely for a figure you have got 1 marks. Don't lose that marks. Okay. So these both are wrong. Now let us proceed. 4 times of shaded region, and this shaded region curve, this curve now is given by this. What is that? Y is equal to root of a square minus x square. Let us, so you can apply any one of the approach. So 4 times of, now this shaded region, which is nothing but this, from where to where? 0 to a. So 0 to a, and it is y dx. But what is y? It is this. So 4 times of 0 to a, this will be root of, y is what? Root of a square minus x square with respect to x. Now this one, at the beginning of this chapter, I asked you to memorize some formulas. Let us recall those. What is that formula I asked to memorize? Integral of root of a square minus x square with respect to x is x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a, and plus c, because indefinite integral. Whenever we are going to quote the formula of indefinite integral while solving the definite integral, plus c should be written mandatory. Now plus 4 times of integral. Okay, then I remove this into. It may be thought later on by the student as one variable x is kept. Okay, till here fine. Okay, so now I try avoid writing that. So yeah, we are applying the formula. So let us go ahead. X by 2 root of a square minus x square plus a square by 2 sine inverse of x by a, and the limit 0 to a. Now by fundamental theorem of integral calculus, let us apply that, which says that wherever x is there, apply the upper limit minus the lower limit. Now for as it is, wherever x is there, a, come on, just see a here, then root of a square as it is minus a square, then plus a square by 2 sine inverse of a by a. This is upper limit minus, let I give a floor bracket to have a difference between rectangle. This multiple 4 should be given here. I should multiply this, so this bracket should be closed there. So I'll give a floor bracket to have a easy identification. Lower limit is 0, so wherever x is there, 0. So there is 0 here. Then plus a square by 2 sine inverse of 0 by a. Yes. Now I have to simplify. Just see carefully now. What is a square minus a square? 0. And here a and a both will get cancelled, get 1. Okay. 0 and anything is 0. And 0 by a is 0. Sine inverse of 0 is 0. From inverse trigonometric chapter. Sine inverse of 0 is 0. I don't want to discuss much about this. Just memorize. And one more thing, no. Apart from second term, no, first, third and fourth term, all this is 0. But make sure, no, since I said 0, no, I will write whatever I want. The evaluator is, no, already know the solution of this. Okay, those are, no, we should be very careful about our each and every step. They are not going to give the marks just like that. Okay, so give you 100%. Now, so only this. And what I'm trying to say is, even if you don't memorize this formula, even if you don't write the reason also, just you can remember first, third and fourth terms are 0. Now let us move on to the simplification. Only the second term is left out, a bracket here, and then a square by 2 sine inverse of 1. What is sine inverse of 1? Sine inverse of 1 is pi by 2. Memorize this. Now 4 into a square by 2. Then this is into pi by 2. As you can see very clearly, 4 and 2 into 2 is 4. Both will get cancelled. 4 by 4. And the remaining is pi a square. And this is our area, pi a square units, and that is our area of circle. Area of circle. Now, till here, for this part, till here, solution is completed. The additional problem, very simple it is. Just see, I will write the the equation of the circle and whatever they have asked. Again, you are not going to resolve this. No. Whatever the result we have got, final conclusion, with this help you are going to write the solution. First let us write down this. Now compare. What do we have here? In place of a square, 4. Therefore the area of this will be, therefore area of the circle, which circle? This circle, is pi a square. In place of a square, 4. So answer is 4 pi square units. That's what I said, no? Hardly one line. Just have compare and comment it. In case it comes, you are benefited. And it need not be 4. I can give here 7. If I give you 7 here, a square is 7. So answer will be 7 pi. Okay. Thus, if at all they are giving some problem, they can vary the numbers. That's not a big deal. Okay. So make a note of this. So with this, second problem, with respect to what I am solving, model question paper 2, question number 44 of 5 marker completed. Make a note of this. Yes, dear students, we are in the last problem, and this is question from model question paper 1, okay, from case EAB for this academic year. Question says find the area of the ellipse x square by a square plus y square by b square equal to 1 by the method of integration. And again, I have taken an additional problem here. I just wanted to understand that when I take an additional problem, this additional problem, again as a precaution, but the December month, this, now last year, because this is today's 1st January. So the last year, that is December 2025, second quarterly test which you wrote, question, the same question came, and this was a sub problem. So that's what I'm saying. Let us not ignore those. But coming to model question paper 1, which is issued by KSEAB, they have not given the sub problem. Okay. Now you'll be thinking so many things are kept as it is. That's what I said. No, model paper number 1 C. And now from this, what I'm going to explain, one thing will be clear. If I know circle, I know ellipse. It's like buy one get one free. Okay. Let us start. So first I have to draw the curve of this ellipse, and here they are not mentioning a more than b or a less than b, so it's under the assumption that a is more than b. Whether it is a more than b or a less than b, the area will not change. What do you think? Because if a is more than b, I get an ellipse. Of this form. Let me just plot it out. Just want to draw in first attempt only. Till here, perfect. So yes, good. Okay, better. So I want the area, and here this diagram is when a is more than b for this ellipse. If a is less than b, no, the ellipse will be this, a vertical ellipse, we say, the one which I'm drawing, this one. Okay, this we call vertical ellipse. This is horizontal strip. Sorry, this is vertical ellipse. This is horizontal ellipse. I was just discussing, no, vertical and horizontal strip. The strip is coming. Okay. Now see, this area or this area, both will be same. What do you think? Just this is under the assumption a is less than b. See, for example, this marker. This requires some length. So maybe let us say 15 centimeter. Now just see carefully. This, if I tilt like this, what's the length? Again 15. Again 15. Again 15. Even if I know, just throw up, throw down, it remains 15. If I have fixed as 15. So let it be length, area, volume. As and how we change the position, length, area, volume will never change. Okay, that's a basic common sense, because even when you are walking, length will not change, no, height means to say. Now let us move on to this problem. So I want to find area bounded by this ellipse, and I got 1, 2, 3, 4. Again the same logic of circle, whatever the area is there, same as here, here and here. So I want this one to be y equal to f of x. So let us try to remove this, so that no, copying and seeing the things will be easier. Let us not have too many things on the board. I'll remove this also. Yes. Now let us solve for this and try to bring in the form of y equal to f of x. So I'm going to use the blue color ink, so that now you understand what is the new step done, and remaining all will remain same. Just see this. So I'm just writing the ellipse equation again, and then sum of two terms you can transpose here. Y square by b square is equal to 1 minus x square by a square. Here nothing is the denominator for 1, so it is 1 only. So LCM of 1 and a square is just a square by LCM, difference of two terms, as you can see. So I take LCM. So a square is the LCM. A square by 1 is a square. So a square into 1 is a square itself. A square by a square is 1. 1 into minus x square will be minus x square. Then here y square by b square. Then I can cross multiply. When I cross multiply, I get y square is equal to b square by a square times of a square minus x square. Now since I want y, take the square root on both the side, we get y is equal to, again no plus or minus because this particular part, the curve is above x-axis, so I will take only positive. Now see carefully what have I obtained. Whatever I have obtained, y is equal to b by a root of a square minus x square. This term is already present, so only b by a. So b and a are constant, so we are going to keep out. So this area is 4 times of shaded region, and this is bounded by y-axis, whose equation is x equal to 0, and since this length from here to here is a, so this will be x is equal to a. So there is no change in the limit because 0 to a, and this curve is given by this, okay, given by this. So now let us simplify. So in place of y, b by a. So you can see this term is there, only b by a. I will write directly out of the integral b by a. So this integration remaining all same, only b by a. That's what I said. Buy one get one free. Buy one get one free. Now from here we have to be extra precaution. Oh, yeah, no. Yes. Now see carefully what is happening. This a and this a square, one a will get cancelled. So I will get a here and b and pi. So answer is what? Pi ab. Okay. Now problem is completed. If the question is still here, but subproblem. For this subproblem, see carefully. Again, if I compare with ellipse and this, okay. So in place of a square, 9. Okay. In place of b square, 4. So from here, what is a value? 3. And what is b value? 2. Again question will come, sir, when you take square root on both the side, you should write plus or minus 3 and plus or minus 2. This is under the chapter conic section of first year PUC, and there it has been discussed that both a and b are length, and lengths are always positive. A is semi major axis length and b is semi minor axis length of the ellipse. Okay, detail when I take CET class, there we will discuss. Okay. Now, come on, substitute. Let us call this as equation number 1. Put all this in equation number 1. Then area of ellipse here done. And again area of this ellipse, this ellipse. Okay, this ellipse. Area of this ellipse is given by pi. Okay, is AB. What is A? 3. And what is B? 2. 3 2s are 6 pi square units. Done. So we have completed all the 3 model question paper problem from KSEAB. Now before we just go ahead, first make sure this all problems should be crystal clear. And so far, let I just give you, let I just comment. First, I hope all of you have copied. Mistake, okay, it's visible. Okay, now time. See, as per my experience, so far from 2014 till today, I've seen coming to this. I correct myself after the reduction of the syllabus. That's better. Okay, the 5 marker question has been either circle or ellipse. Sin X very rarely asked. Okay, and actually never asked. Okay, but let us not leave that. It's very easy. Okay, I gave the alternate procedure that time. This side, that one you can follow. Okay, that's one. And I just want to give some assignments. Okay, I'll give that also. Now, coming to December month quarterly, second quarterly test from PU board, there was one question asked, y equal to 3x plus 2, find the area from -1 to 1. That question also I would like to cover. It came for 5 marks. Let us not leave that. So with that, everything will be completed. Okay, let us take one problem on that, the last problem, and that problem will be taken as extra when we compare to all the model question paper, the 3 model question paper. Dear students, so we are at the end of this chapter, and this question which I have taken has come, asked in second quarterly test, December 2025. Okay, the recent test which you wrote, and this came for 5 marks, question number 23. So, but this is not been asked in model question paper, all those 3 model question paper. But I thought let I cover, okay, and it will be a end of the all concept. Now let's try to go ahead. Question is find the area of the region bounded by the line. Even if they have not mentioned the word line, it's understood. Why? For only line, the variable degree is 1, nothing but it should be a linear, and it is bounded by x-axis and the ordinates x equal to -1 and x equal to +1. So this is already solved in terms of y. So first let us try to find find the coordinates. See, it's a line, and we know that every line will pass through, I mean to say unique line, okay, will pass through 2 points. So I've just discussed in linear programming problems, whenever constant is non-zero, I can always think as taking x equal to 0 and then get y value, and then take y equal to 0, get x value. So when x is equal to 0, we get y is equal to 3 times of 0 plus 2, and here I'll get 0 plus 2, or y is equal to 2. Whereas when y is equal to 0, let's say this as 1, I have put in 1. Okay, again if I put in 1, we are going to have 0 is equal to 3x plus 2. So I am transposing here, 0 is equal, when I'm transposing, what I'm going to get, sorry for this, when I transpose, I get -2 is equal to 3x, or x is equal to -2 by 3. Therefore I can say I have got the coordinates here to be 0, 2, and don't forget always x comes first, then y. So x value is -2 by 3 and y value is 0. So I have to plot the graph of this. Let us try to plot, and this is just more than -1. So let us have the graph. So somewhere -1 here, and here, so it is between -1 to 1. So okay, 1 here, and somewhere here 2. Yeah, because y value is 2. Now if I join this line, join this point, okay, fine. This line is y equal to 3x plus 2, and there is a vertical line at 1, 0 here, right, 1 here. So draw this, and this is perpendicular to x-axis. So I have drawn, but oh, hold on, this is -2, 3, no, so this is -2, 3, and -1 will be somewhere here. Okay, a correction there. Now I have to find the area between -1 to +1. So see this is x equal to -1, and this line is x equal to 1. So I have got this small triangle below x-axis and this a big triangle above x-axis. Now since this is lying below x-axis, so the fourth concept which I have taken, that I have taken modulus here, and this is without the modulus. So this one, just see carefully how we are going to go about. Now this area is given by, let us name this. So yes, we are going to find the area. As I said, that this is bounded below x-axis, this is above. I have just given the naming for our reference. Now just see carefully. The area of this region, which one? DC, see this, from DC, then BA, and then again CED. So DC, BA, CED. I want this area. I just name from like this. See, DC, then goes here, B, then come here, A, then C, and again covering this. This particular triangle, that is area of triangle, which one? DCE. I will give under modulus because it is below x-axis. Surely the area will be negative, and we are breaking at minus 2 by 3. Then integral, then plus, I mean to say, then area of triangle, which one? ABC. Okay, so this area and this area we have to find. Okay, now let's try to find one by one. Now next, area of triangle DCE. This is this area is from minus 1 to minus 2 by 3, and this particular line, okay, is given by y equal to 3x plus 2. So 3x plus 2, then dx, plus this bigger triangle is from minus 2 by 3 to 1, and it is 3x plus 2 dx. Okay, now since this area is negative, I am giving a modulus. Now I want to highlight the point that when I evaluate repeatedly for this, I'll give a blue color modulus. I will cover this by modulus of not with blue color, so that we will always see that are we getting negative from this or not, and it should be a negative there. Now some of the formulas which are already quoted. Integration of x power n with respect to x is x power n plus 1 divided by n plus 1 plus c, where n is not equal to minus 1, and integration of a constant k with respect to x is kx plus c. So these two formulas let us have for evaluating from here. So integration of this, I have to apply some rule, and for this scalar rule here, so 3 is a constant, keep as it is. Integration of this x, power of x is 1, so in place of n it is 1, so put here x power n is 1, 1 plus 1 will be 2 divided by 2, then plus 2. Integration of k is kx, where k is a constant. K is a constant and it is a real number. So integration of 2 will be 2x. Applying the limit from minus 1 to minus 2 by 3. Then again same thing, 3x plus 2, the same, so I can just copy this one back here because it is the same integrand to be integrated. So minus 2 by 3 to 1. Now let us apply the limit upper minus lower. So here we have 3 by 2, upper limit is minus 2 by 3, so minus 2 by 3 the whole square, then plus 2 times of minus 2 by 3. So wherever we have x, we have applied the upper limit, then minus lower limit. Lower limit is minus 1. So again here 3 by 2 as it is, minus 1 the whole square, plus 2 into minus 1. So for this, see this entire thing, I am giving a modulus because that is the outcome of this, okay, which is below x-axis. Now again for this, plus 3 times of upper limit is 1, replace everywhere. I think I just forgot to write 2 here, just copy it back here. So 1 square plus 2 into 1, then minus 3 by 2, minus 2 by 3 the whole square, plus 2 into minus 2 by 3. Let us cross check, have we applied the limit correctly? There should not be any error. Minus 2 by 3, yes, fine. Okay, and then upper limit and then minus lower limit. Okay, fine. I just crossed it. There should not be any error. Now let us simplify. So 3 by 2 minus 2 square is 4 divided by 9, plus into minus minus, 2 2s are 4 by 3. Then here minus into plus is minus, 3 by 2 into minus 1 the whole square is 1, 1 into 3 by 2 will be 3 by 2, minus into minus will be plus 2 here, and this entire thing should be under the modulus. And here you can just see, we can further simplify here. It is 3 1s are, 3 3s are, then here 2 1s are, 2 2s are. Okay. Next, the term outside the modulus, that is plus. Here 3 by 2 into 1 square is 3 by 2 plus 2, then minus 3 by 2 minus 2 square is 4 by 9, then minus 2 2s are 4 by 3. Now from here simplification for this also, 3 1s are, 3 3s are, 2 1s are, 2 2s are. So let us further simplify. So we are going to have 2 by 3 minus 4 by 3 minus 3 by 2 and plus 2, and here 3 by 2 plus 2. Before I forget, modulus should be given from here till this term, so it means we will get negative from that, and that term without modulus will be ultimately positive. Okay, minus to plus is minus 2 by 3, then again minus into minus is plus 4 by 3. Now let us take the LCM. LCM of 3, 3, 2 and nothing is a 1 will be 6. 6 by 3 will be 2, 2 into 2 will be 4, 6 by 3 will be 2, 2 into minus 4 is minus 8, 6 by 2 will be 3, 3 into minus 3 will be minus 9, 6 by 1 is 6, 6 2s are 12. So again this will be under the modulus, whereas here 2, then 1, 3, 3, the LCM will be 2 into 3, okay, 3, 6, 6 by 2 will be 3, 3 3s are 9, 6 by 1 will be 6, 6 2s are 12, then minus 6 by 3 will be 2, 2 into minus 2 is 4, 6 by 3 will be 2, 2 into 4 will be 8. LCM, that's it. Now simplify this. We can just see here minus 9 plus 12 will be plus 3, and 4 minus 8 will be minus 4. So I'll get minus 1 by 6. And you can see that the term which was under the modulus, ultimately we got negative, and which is obvious because of this. I'm repeatedly stressing this point to make you clear, and this should be positive. Let's see, minus 4 plus 8 is 4, 4 plus 12 will be 16, 16 plus 9 will be 25 divided by 6. Now taking on mod, minus 1 by 6 will become plus 1 by 6 plus 25 by 6. So we are going to have 26 by 6. Divide this, 2 1s are, 2 3s are, and 2 3s are, 13 by 3 square units. So this will be the answer. Problem was not difficult, but we had some calculation to be shown. So hope so it is clear. Let us try to have some assignments. I would like to give some assignment for you all. The first assignment will be, okay, so let us have some ASG, I will call as assignment. The first question will be, find the area bounded by the ellipse x square by 16 plus y square by 9 is equal to 1 by integration method. Actually, this is your first exercise problem in exercise 8.1, and what ellipse problem we have taken. Just you can see throughout whatever I have taught you, wherever a square is there, you can replace by 16, and wherever b square is there, it is 9. I repeat again, wherever a square is there, it is 16. Wherever b square is there, it is 9 in this equation of ellipse. So wherever a is there, it is 4. No plus or minus 4 because a and b both are length. Length cannot be negative. And b is equal to 3. So throughout the derivation, we can just replace and you will get the result. This is called bonus. Buy one get one free. Not only that, we have got one more problem. In same exercise 8.1, the second question is find the area bounded by the ellipse x square by 4 plus y square by 9 is equal to 1 by integration method. So again, in the same problem where we have got ellipse, we are going to replace wherever a square is there in this equation. Wherever a square is there, you have got 4, and wherever b square is there is 9. So a is equal to 2 and b is equal to 3. If this question is asked, you have to be careful that since a is less than b, your ellipse will be a vertical ellipse. It won't be a horizontal ellipse. The derivation which has been done, it is under the assume that a is larger than b here. So for this, my ellipse will be a vertical ellipse, a standing potato, which I call during the class. Okay. So let us have this one proper. Okay. Okay, fine. So this is origin, this length will be 2, and the procedure will follow. Okay, whatever we have got for this. The last problem, which may be a 5 marker, is find the area bounded by the curve y equal to cos x between the lines or ordinates x equal to 0 to x equal to 2 pi. As we know already, for cos x we have already solved. Now it is for, sorry, I think already we have solved for sin x. Now it is for cos x. Okay. Yes, dear students, we have come to an end to the chapter application of integrals. Hope you have enjoyed, and we have covered all the 3 model question paper along with the concept, and even we have taken December month second quarterly test question also. And I will make sure that in the description I am going to provide the link of all the chapters which I have covered so far. So do like, share and subscribe. All the very best. Study well. Give your 100%. All the very best. Thank you. And God bless you.